In terms of the standard terminology for additive manufacturing, we can say that it is a process of joining materials to make objects from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing methodologies. There are other synonyms like additive fabrication, additive process, additive techniques, or even freeform fabrication. The 3D printing is another term that is often used with additive manufacturing, but in particular associated with machines that are low-end in price and or overall capability. Rapid prototyping is use of additive manufacturing and subtractive techniques to obtain a prototype, namely a part with limited functionality. This prototype is a different material or similar than the final part. Typically, prototypes have one of the following uses: as a visual, in order to make a demo to a customer. We can use it as design aid for a mold designer, for example, or as functionality test to test the mechanism, for instance. There are 7 additive manufacturing technologies: the vat polymerization, material extrusion, material jetting, binder jetting, powder bed fusion, direct energy deposition, and sheet lamination. The additive manufacturing technologies has a lot of benefits. One of that is greater design space, and we don't need tool to make the prototypes. The on-demand is making anywhere. We can make prototypes in hours, not in months. The customization is almost free, and we can use the material efficiently. The additive manufacturing technologies are still in development, but in general, for the customers' values, we can say that we can decrease the costs of second operations. We can reduce the cost for the production, and we can reduce the cost of warehousing and logistics. For the customers, we can also reduce the time of developing time. We can reduce the cost of high degree of complexity, and we can reduce the cost of materials for each part. In terms of comparing the cost per part and in complexity, it is well known that additive manufacturing remains the cost almost constant when we are increasing the complexity. Comparing with traditional manufacturing, the costs will increase when we increase the complexity. In terms of the main advantage of using prototypes, we can say that the prototypes plays a vital role in the process of creating successful products because it speeds up the new product development process, so we faster new product development. We can use it in the early stage design concept validation of the form, fit, and function of the design. We can use it also in the final stage in order to make product verification against the technical requirements and business objectives. And we can use it to allow functionality test to test the objectives of the concept and to finalize the specification. The prototypes gives of the end user, client, customer, user participants, hands-on user experience to get feedback and to refine the requirements. In general, and more specifically, we can say that the using prototypes reduce the design and the developing time, reduce the overall product development costs, eliminate or avoid reduce some of the risks, allows the functionality tests, improve and increase user involvement, which makes the ability to evaluate human factors and ergonomics. We can say also that there are some space to improve the rapid prototyping techniques, because some of the techniques even continues to have lack of accuracy during the production of the prototypes. But we have also added initial costs, and some prototyping processes are still expensive and not economical. Some materials properties like surface finish and strength cannot be matched and require skill level in some technologies. The range of materials that can be used is still limited for some technologies, the overlooking some key features because it cannot be prototyped. End user confusion, custom mistaking it for the finished project, developer misunderstanding of user objectives. The question that we can make is, which types of rapid prototyping techniques I should use? The choosing of the right rapid prototyping technology is critical to the success of prototyping. It's well known that we have a lot of rapid prototyping technologies, and each of one is specific, or we can make use of them specifically for a specific prototype production. Each rapid prototyping technique has its own compromise in terms of the cost, speed, material compatibility of the feature, fidelity level, and developing stage. Rapid prototyping doesn't need to be limited to one process. One can use more than one manufacturing techniques to assemble a prototype. This is one of the reasons that we create DunLab. DunLab is a laboratory that was a joint venture with the Carl Bosch Multimedia and University of Minho. It's a laboratory for advanced manufacturing of products and tools. Our strategy is divided in three main areas: the digital manufacturing, engineering design, and research and innovation. In digital manufacturing, we have capabilities to do production of C-samples, assembling line tests, prototypes for supplier issues and solve problems. We are able to support the suppliers of Bosch Multimedia in order to avoid some problems that they have, to produce parts. In terms of engineering design, we support the industry challenge, mainly the suppliers of Bosch Multimedia, to produce jigs and tools for the factory, product design and development, design for additive manufacturing, and we can make reverse engineering and metrology and quality control. In terms of research and innovation, our main activity is in hybrid molds, using standard structure with insert molding made by additive manufacturing. We use design for additive manufacturing to improve products using optimization topology and generative design. We develop new concept of products, new rules, new materials for the different technology that we have, and we have also academic mission. We do some workshops and support classes. In terms of the technological areas, we are divided in 5 main areas. The main is the additive manufacturing, but we have also subtractive manufacturing with the milling machine, reverse engineering and metrology, post-processing, and formative processing with a vertical injection molding machine. In terms of the resources, human resources, we have 14 members. Some of them are PhD students, but the main staff has a PhD. In terms of the competencies, we have several softwares for CAD, 3D and 2D, CAM and CAE, Computer Aided Engineering, like Moldflow, Moldex, ANSYS, Abacus and CST. We have also some capabilities to characterize materials and products, namely electromagnetic compatibility. For the finish, we have several technologies, namely painting technologies, thermal treatment, and we do also some design for additive manufacturing research. In terms of technology, as I said before, we have several, but our main is to use it to produce products, but also to produce inserts for molds. So we have also the capability to design molds and to make scan for reverse engineering and metrology. We use also our injection molding machine to produce short series of production and produce hybrid products. And we use the optimization topology and generative design to make optimization of products and prototypes. In terms of research areas, we have 5 main areas. One is the technology process. Second one is materials, design, hybrid tools, and hybrid products. But we have another mission, which is the training and the formation of our students and support the classes. Now we will talk about the technologies that we have inside the DAN lab. The first one is the power bed fusion. First, we make the data preparation, the nest, and after we make the production. After we do the production, we remove the parts and the frame from the machine. Some precautions we should take care because inside the machine the temperature is quite high. And after we removed the frame, we go to a next station in order to remove the parts inside the frame. This is an operation is quite fast, and after we remove the parts which is inside the cube of powder, and this powder will be used to another production. So we have a recycling of the material. After we remove the parts, we can go to a station in order to part cleaning with the compressed air, and a very careful cleaning of the machine should be done. Another technology that we have inside is the power bed fusion with laser for metals. In our case, we are using aluminium, and after we made the data preparation, we start the production. After the production, all the frame and the sample are removed from the frame, and inside we should remove all the powder that will be reused in the other production. So we make the recycling of the material. The frame is screwed in a platform, and this platform should be removed from inside the machine of the machine. You can see also some supports, and these supports should be removed using a milling machine in order to cut all the supports that are in contact with the, in this case, with the insert molding part. Another technology that we have inside the DAN lab is the material extrusion. We have 3 machines for material extrusion. One is the Mark II from Markforged. We are able to see all the processing. We start with the data preparation. We select the number of the layers to produce the part, thickness, the orientation, and to select also the location of the part inside the machine. After we have done the preparation, we put the material inside, control the machine. The Markforge, we can use the polyamide or continuous fiber, carbon fiber in this case. We are able to see all the operations inside, and in order to see all the details and if something is not correct during the production. Second machine is the Forge 900 from Strategies. We have the several canisters and we put the canister inside the machine. We made also the preparation of the machine, or we can change the nozzle, the different nozzle or different thickness of the layers. And after we make the production, and we can remove the part from inside the machine, and we should take care about removing the parts from the foil. After we remove the foil, we can put the part inside a tank with a specific liquid in order to remove all the material support. Third machine is the Robos, and this is a machine where we can use own material, so we can produce filaments, and after we can make a canister with that filaments, and we can produce part with the specific material. In our case, we have the capability to produce filaments, specific filaments, for instance, with conductive material, electric and thermal material. Another technology that we have inside the Dunlap is the material jetting. The material jetting uses a photosensitive polymer that cures with UV radiation. After we make the data preparation, we put the material inside the machine and this starts the production. In our machine, we have 2 lamps of UV radiation, and after the production, we can remove very easily the part from the machine. And in order to remove the support material, we go to another station in order to clean with the water, and after we finish the part. The last technology that we have inside the Dunlap is the verticalization. In this case, we use resin that is also photosensitive. In this case, we use a laser controlled by mirrors, and after the production, we can very easily clean the part with a special station. And after we remove the part from this station, we can use another station in order to make a final cure or post-cure of the part of the material, and in the end we make a final remove of the supports and a final finishing of the parts. We will present one example of production of a safety shoe using the polyjet technology. First, we start with a combination of the materials with different hardness, and after we finish, we can start the production. During the production, the machine, layer by layer, and using a combination of different materials in terms of the colors and its hardness, we can build the prototype at different stage and with different configuration. In this case, we can see the machine in the fast motion, but this technology takes a lot of time to produce the whole product. Here you can see the shoe and with the supports. After the production, we remove the shoe from the machine and we start to remove the supports, and now we will show you the final product. Here you can see the final result obtained using the polyjet technology. In this case, with different combination of different resins, which is photosensitive resins, we can combine different colors, different combination of black and white, and also different combination of hardness material. So you can, in this zone we have a more hardened material, and in this zone we have a more elastomeric material. So as you can see, we can stretch the material, and in this case no. So we can see that we have more hardened material in this case. And we can see how is the behavior of the prototype, and we can see how is the perception in terms of the ergonomics features also. And this is a technology that is very useful for the designers and also to the customers in order to see the final results obtained during the design and during the product development. Another technology that we have using is this one, which is a small part, and you can see very small features in this case with letters or lettering, and this was done using SLS technology, selective laser sintering technology, and in this case we use powder and is powder material. The material is polyamide 12. Is a very interesting technology to produce a lot of series of production. In the same batch of production we can produce more than 50 parts for each frame, and this technology is very economic in terms of its production, because we can produce in the same series of production a lot of parts. And it's very interesting also because we can produce parts with a very accuracy and with good precision in terms of small features.
Good morning. I hope that you enjoyed this morning events, and also that you enjoyed the additive manufacturing workshop. Now I am available for any question that you could may have. Perhaps now I have one here. So the question is how to select a rapid prototyping technology. Well, this is quite difficult to do, because we have at this moment a lot of technologies available for additive manufacturing. Also, they are open new materials, not real rubber material, as another question this is made. But the main factors for to select additive manufacturing and synthetic technologies are the purpose of the prototype, the quality of the prototype, the quantity needed, the complexity of the prototype, and the cost of that prototype. This is the five main factors for selecting a prototype fabrication technology. In terms of the purpose, it is very important that depends on in which phase the product development it is. So if it is information design, concept design, detail design, or pre-series, so this is the different phases of product development phases. And depending on this, we can choose different technologies. For instance, if you want to make only information, it's very common to use for additive manufacturing parts or assemblies. It's very often to use the FFF technology, or stereolothic SLA or SLES technology to do that. Another issue is the quality of the prototype. In terms of the quality, if you want, for instance, to the fidelity or the accuracy of the product requirement, will command the process and post-processing that we'll need to achieve that tolerances, for instance. Also, the lifetime of a prototype is also critical in these cases when we decide to technology. For example, if the parts have fasteners that will be used frequently in different assembling issues, then machining or even metal insert is more interesting to do that. In terms of the quantity, also this is a very important factor, and the number of required prototypes are very important for this decision. So in summary, I will say that when we are the new engineering product development almost always involves making prototype to test ideas and functionalities. And in order to make a rapid prototype selection process steps, we should take care. Define the purpose of the prototype for which we want the prototype, establish the level of approximation to reproducibility or fidelity of the prototype to real purpose, outline the evaluation of a method and plan to identify the quantities, and ensure that your costs is kept within your prototype budget. So this is the 4 main steps in order to select a rapid prototype. In terms, another question is what is the softness TPU which is available at this moment? At this moment we could produce with a short A about 35. So this is the what we have available at this moment. In terms of the Dun Lab is in fact a joint venture from University of Minho and Boscar Multimedia, and we are open to help the industry in Portugal or in other country around the world. So we have it is very easy to find our website and to make the question, and we can have if you could make a solution for you or we can help you, we'll do that definitely. If another question is if I believe that 3D print can be an industrial solution in the future to support the footwear industry, I will say yes. We have some examples. Normally, the problem is the final material for a specific component of the shoe, but more and more we have a lot of material solutions for additive manufacturing. Even with the electrostatic discharge properties, material with the ASD properties. And but another solution for that to produce the final products is to use the concept of hybrid molds. So we can produce mold inserts in the standard structure, so we can inject the material to inside in a very few hours. So we can produce very fast the inserts, and we produce the products with I will say the final material. But in the future, I believe definitely that we will have more and more materials available for additive manufacturing, and this could be a very interesting option for shoe industry. Well, I don't know the maximum, because the maximum size for 3D printing, because depends a lot of the technology. What we have inside is 1 square meter size. So we have available to produce 1 square meter in our Fortus 900. Not real 1 square meter is 1 meter by 600 millimeters, but there are other options to produce these kinds of parts with the big dimensions. Yeah, printing injection molds for million is may better than printing final parts. Yes, I agree with that. We have some experience on using hybrid molds and produce mold inserts for injection molding. Another question is how much time does it take to develop new products? That depends. Our experience is more and more we are using the additive manufacturing in order to make faster the product development. So since the beginning, we produce prototypes, we test the prototypes, and we use this kind of methodology in different cycle product development. And our experience is that we go faster when we produce prototypes since the beginning of product development. I don't know if there are any questions. If no, I think it's the lunch time at this moment for some of you. So now I have other questions. So regarding the costs, the cost is quite difficult to estimate, depend on the dimension on the type of technology, and also the time that you require to produce the prototype. So it's not a simple question to do. In terms of the additive manufacturing will be able to produce parts for shoes, I will say yes. And we have also some materials that are very similar to the shoes, depending on the propose. So in terms of the leather, perhaps is more difficult to produce, to use additive manufacturing to replicate the leather material. But there are other components of the shoes that definitely we can use the additive manufacturing to produce that. In terms of the textile, I will say I don't have an answer for that. What we are using is the textile as inserts, and we use the textile in assembling of additive manufacturing production components. So we use the textile inside the additive manufacturing products. At this moment, our experience is to produce the 3D objects in different colors and in different hardness. And I will say that we are able to produce a lot of components with with a lot of colors and combinations. So in terms of the design, it's very free to produce different products and with different components and with different colors and hardness. Yeah, another is to use to produce 3D logo structure on 3D objects. Depends on the definition that you want to the 3D logo. So if the 3D logo is something that is not really a printing, but you can have some features, it is possible. Also, it is possible to produce in polyjet technology, the material jetting technology, different colors, and in some cases, depending on the dimension of the logo, you can print, I will say, a logo. So it is possible to do that. In terms of the developing a new product, that depends on the dimension of the prototype. As I said before, what I can tell you in my experience, and more using the prototypes at the beginning of the product developing phase, we accelerate the prototype development and we short the product development. At this moment, we are doing product development with our medical school in the University of Minho. And in this case, we developed a new product in 9 months. So, but depends on the product that I mentioned, the complexity and so on. Yes, another question is, it is possible to combine different materials in 3D? Yes, it is possible. We have some examples that we combine the different components produced with different additive manufacturing technologies, and we use it as insert inside the additive manufacturing technologies. We can produce aluminum parts, for instance, and we use it as insert inside the material extrusion technology, or even with the polyjet machine. In the polyjet machine, we also use the textile as inserts, and we produce a component with a textile around that material. So it is possible to combine that. Another technology, another developments is the new materials, and what is growing very fast is the materials for material extrusion. So it is possible to produce filaments with specific functions, like with the thermochromic materials. So materials that can change the color with the temperature and other functions. So they are a great development in the recent years. We have one case inside the Dunlap, so we produce filaments that change the color with the temperature. Of course, at this moment is some limits, but it's possible to have in near future a lot of materials with different functions and with a specific function for specific products, and also for shoe industry. In terms of the evolution and the use of additive manufacturing for real production, we have at this moment some experience on that with the Bosch Car Multimedia in Braga to produce some parts for testing, but also some of them was already assembled in the real cars. At this moment, we can produce medium series, I will say, until 1,000 parts by additive manufacturing. And this is economic efficient. So we can use the additive manufacturing for real production in some cases. At this moment, our experience is about 1,000 parts, but I will say that in near future, depending on the application, perhaps this number could be increased. In terms of the molds, we use aluminum for aluminum inserts, but for molds. But we have also in the ULTEM, we can use ULTEM. So it's a material for high temperature. And it is possible to use this material for injection molding. And we have some experience on that. Also using digital ABS, which is a material for material jetting. And it is possible to use it also for injection molding inserts. Yeah, it is possible to use different colors for the same product. One example is using the material jetting technology, the polyjet material. In terms of the costs, comparing the aluminum milled molds and 3D printing injection molds, that depends essentially on the number that you want to produce. In some cases, if you produce a very fast short series, I will say that using additive manufacturing with known metal materials, it's interesting to use it in terms of the time to produce the parts. We did some production recently, and we compare both. And for short series, we can have good reproducibility using for instance, the ABS digital or digital ABS material. There another question regarding to get the TPU parts where you will print them partially and then in our traditional injection molds, so we can create sandwich structure. In our case, I will say yes, but we say this, we produce these kinds of sandwich structure using the different hardness of the material. So we can combine the different hardness of the material. So we can create out layers with more hardened material and inside some flexible material. But it is possible also to use the lattice structures. So structure that in combination, we can create like a sandwich or can create different rigidity zones in a product. So it is possible to create a very complex geometry and take advantage of the material and of the lattice structure in order to create parts with more rigid or less rigid. So it is possible the design is quite free at this moment using the additive manufacturing technologies. Yeah. I have another question. Perhaps I didn't understand well, but the standard, but inserted in our injection molding process 3D parts. Another capability or another solution that we could use is to produce, in fact, additive manufacturing components and use it as insert in an injection molding machine. With that is what we call the hybrid products. In this case, depending on the geometry of the additive manufacturing component, we assemble it in an injection molding mold or machine, and we over-inject, and we have different products. So products can be personalized, and we can change the type of product as you wish, keeping always the mold structure. Yes, the material or the products from IM can be recycled. We have this possibility, and I know that there are other people that use it, so they can recycle the additive manufacturing materials. I don't have the hybrid product with me, but I can share. You have my email, and I can share more information if needed. So if now perhaps you don't have more questions, I would like to thank you all for your presence in this workshop. You have my contact in my personal data, so if you want to contact me by email, so feel free for that. And have a good day, and thank you to all.